Mayur. Welcome to ML Works. Today we'll be talking about what is computer vision, why we need computer vision, and some of the basic units of computer vision. So first let's get started on the topics. So what is computer vision? So computer vision is a field inside AI, okay, and where you have computers, okay, trying to understand or trying to learn digital data. What I mean by digital data means videos or a combination of what images. Okay, so anything a computer learns from digital data fall under computer vision. Okay, so why we need computer vision? So why computer vision in the first place now? So if you go to your mobile phone, you will probably have any of these apps: Facebook, Instagram, or Twitter, or you have TikTok or YouTube. All these apps what have this facility or an utility function where you upload an image or a video. Okay, so these are some basic utility functions provided by these apps, and these apps are the one of those widely used apps in the world now. Okay, so all these organization, okay, or people who are using these organization has in their own what has a tool for what, for a business, as a business tool, who are using these tools as a business tool for some organization. What they'll do, they want to what, find out insights from these data. Okay, so for that purpose CV is important, computer vision is important, okay, in the business perspective. Okay, business perspective. Now we have understood what is computer vision. Computer learning from digital data is computer vision, and why we need is because it's widely being used. Data like images and what videos are widely being collected everywhere, and we need to find out what insights from these data. So we need computer vision. Now, what is the basic unit of computer vision? Basic unit of computer vision is an image. Okay, this is the basic unit of an computer vision project, or not a project, or you can call it like the data aspect of computer vision is an image. Okay, even a video is a frames of images. Okay, so our fundamental unit for computer vision is an image. So what is an image? So image is nothing but a multi-dimensional matrix. Okay, so multi-dimensional matrix. Consider a black and white image will have about one channel. Okay, these are the channel is nothing but a color model. For example, a black and white image will have height, will have width, and it will have one channel. Okay, when you have color images, okay, you will have three channels, multi-dimensional matrix. Okay, so here you have RGB channels of height, each with the same height and dimension width. Okay, this is the basic fundamental unit. This is for black and white images, you will have one channel, and for color images you will have RGB. These are fundamental color models actually, and there is also something called as HSV, which is widely what understood by humans. Hue, saturation, and value. So this is a this what RGB model, right? Let's go to another page. So first go to like RGB model is a three-dimensional model of colors. So it is represented by a cube actually. Okay, this is represented by a cube. And there is something called as HSV model, like hue, saturation, and value, which is a cylindrical color model. Here you will have something called as, you have this cylinder. So my drawing is not that great, but anyway. So you have this values, V value, you have something called as saturation. There is something called as hue. Sorry. So hue represents colors of your from colors of your spectrum. Okay, different colors. Value represents the brightness, and saturation represents the percentage of purity of the color. Okay, these are some different aspects. So whenever we are trying to play with colors in an image, it will be better if the image format or image color model is in HSV. Okay, we'll see that in another few minutes actually. So here we have seen what RGB model, which is a cubic model. You have what three-dimensional RGB, like you can consider RGB three-dimensional model. Here you have cylindrical color model, which is hue, saturation, and value. Value represents the brightness of the color. So if you have so here also you have to remember, like, there is, since this is brightness, it is represented by 0% or 100%. Okay, so when you have 0%, it is completely dark, it represents darkness, and if it is 100%, it is pure color. And similarly for saturation, it is also represented in between what 0 to 100%. 0 to 100%, and 0% represents it is in gray for color. Okay, and 100% represents the pure color. And similarly hue represents, this is, since it is like cylinder, right, you have this kind of circle. Okay, at 0 degrees you have red color, and 120 degrees you have something what green color, and then under 240 you have something called as what blue color, and all these in between you have different colors also. Okay, it is represented in this format: 0 degrees, 120 degree, and 240 degrees. Okay, so this is with respect to RGB and HSV model color models. Now what we'll do is we'll try to understand images. Okay, the basic unit of images, how we can manipulate those images to do some task. Okay, let's move to the notebook which I've already prepared. Okay, so here what we'll try to do is we'll try to select an area of interest in our images and use color threshold to what segregate those area of interest from the background. Okay, so let's get started. So first what we are doing is we are importing the relevant packages for our task. So here what we have is we have an OpenCV, okay, library we are importing, and then for visualization we are importing matplotlib, and then we are for numerical computation we are using numpy. So we are importing that one. Okay, so here what we are doing is first will be what reading an image, and then we'll find out the dimensions of the image and then plot that image. Okay, this is like since we are using OpenCV, right, we'll be reading through OpenCV. So what is the evolution image we are importing? Let's see. So let's go to, yeah, so this is our evolution image. Okay, this is what we are importing, which has a background of blue color, and we have this bunch of objects, you can say, like human evolution, this asteroid, dinosaur, and RNA DNA sequence. Okay, so we are importing that image, and we are taking the shape of the image, we are plotting it. Okay, let's do that. So if you see now, this background, if you see, right, it is in blue color, and when it comes to when you are importing using OpenCV, it is appearing as what, brown color. The reason behind this is because OpenCV, right, when we are reading it like this, I am read, okay, without any parameters here. Okay, so it will read it in BGR format, blue, green, red. So when you have this different way of overlapping this matrices, then it will result in this kind of color. Okay, brown color, the blue is appearing as brown. And also we can see the dimension of the image. Okay, this is like 900 is the height, and 1440 is the width of the image, and 3 is the what channels, 3 different channels we have, RGB. Next, what we'll do is we are creating a copy of this image, and we'll try to convert into RGB format, which is how we what the in real time it is looking like. Okay, so we'll convert that into, first we are creating a copy using NumPy. Okay, NumPy, like this is another nothing but a multi-dimensional matrices actually. Okay, so just let's see what is this. So if you can see, right, this is a dimension or multi-dimensional matrices. So we are creating a copy of it, and using OpenCV we are converting it into RGB. Now we are again plotting it. Let's see how it looks like now once we are converting into RGB. So this is what it looks like. What is our image? It is the same thing we are seeing here once it is converted to RGB. Now what we'll do is, since there is a clear difference between the objects and the color, the background color, what we'll do is we'll find out a threshold for this color, that blue color, right? There is a threshold present for this blue color. You have, like, for consider you have dark blue, light blue, okay, and between that you will have shades of blue. Okay, so beyond light blue you will have some other color, after dark blue you will have some other color. So there is this lower and upper bound for the blue color. Okay, so we'll find out that range, okay, for this blue color, and we'll try to create a mask for this particular image. Okay, so what we are doing here is we are creating the lower and upper threshold for the blue color here. Okay, and using CV2 in range function we are trying to create a mask, okay, which will try to darken the objects, and take out only the threshold aspect, right? It will take out those alone. Okay, so whatever the objects which are not present inside this mask will appear as dark, and whichever it is present which will appear as white. So our mask is applied and the masked region is appearing as white, and the objects which are not beyond the threshold are appearing as dark. Now what we'll do is, since we are only interested in the objects, we'll nullify these colors actually. Okay, we'll remove these colors, the blue color of the background, by using something called as, like, converting those values as 0 0 0. 0 represents black, and 255 value 255 represents white. So we are turning everything into 0 and making it dark. Let's see how it looks like. Okay, so if we see here, once we are converted into word dark, we are again turning that BGR, okay, that masked image, to RGB. Okay, and we are seeing how it is looking like. We have just taken out our objects of interest, and we are just plotting it. Now what we'll do is, since we have already extracted, we have a mask where we have collected our objects of interest. What we'll do next is we'll read a new image, and which will be converted into the size of this image, the object, right? This is in 900 into 1440. So we'll convert that and resize into this size, this object size, and then we'll be replacing the background. So for this, if you see here, we are taking the space image, okay, which is the space image. Yeah, this is the space image of higher dimensions. Okay, this is more than, this is like 900 into 1440, right? This is more than that. So we have to resize this image such that we can fit our objects into this one. So here we are taking the image, reading the image, then converting into RGB format, and again here we are converting, resizing the image to 900 into 1440. Okay, this is, it will take from one corner aspect, right? Like from this aspect it will take from here to some 900 and 1440. Okay, and let's see. Now this is the image actually. Okay, so we have taken that corresponding dimensions, okay, from this image. Now we will be replacing. So we have created this thing right here, this masked image, which is in RGB format. We'll try to impose this objects on top of this particular image. Okay, so how we'll do this one? So what we'll do here now, so this is creating a masked region on the new image. So here what we'll do is first we'll create that region where these objects have to be present. Okay, so since we have this mask, we'll be turning that into black. Okay, so this region, right, wherever that masked region, we are taking that and just putting it as 0 or black. Now here we have to put our objects. Since we have already identified the location where we have to put our objects, now we just have to impose it. So here we are doing our image masked RGB and the background image, whatever we have cropped, right, 900 into 1440. Okay, so yeah, so we are able to extract an object from an image, change the background, replace it with the new background using OpenCV. We are doing it right now. So next what we'll see is, this is one task which we have completed now, like selecting an area of interest and moving area of interest in an image and moving it into some other images. Now what we'll do is, we have seen this is with respect to RGB format. Now we'll look in terms of what HSV and do some separate task actually. This is color detection. So as I said earlier, right, here we are representing what HSV is, a cylindrical color model, and it represents value, saturation, and what hue, and value represents the brightness. Okay, so this color model this color model reflects the human's perspective actually, how humans look at the object. Okay, so we'll try to use this to complete another task. Okay, so what we'll do is, first we'll import an image, color balls, a different image with what different set of balls. Okay, color balls, and you can see in this image, like we have like different colors balls, yellow, red, green, everything. Okay, now what we have to do is, we have to do some color detection. Okay, so for that we have to understand the range of each color actually. Okay, so we have to extract those particular range, and we have to identify. Okay, so let's see. First we'll just look at what different channels first of all. Okay, since this is RGB format, now we'll look at what each of those channels, how it looks like. So first is red channel we are looking at, then we have green, then we have blue. So if we do this, we'll see some different sets of images, 3 images of different, it will show in different aspects actually. Under red channel, how it will look like actually, and under green channel how the objects looks like, and under blue channel how the object looks like. Now we'll be converting this RGB into HSV, and then we'll use the value aspect of HSV, which is the brightness, right? It will be improving the brightness. Okay, so we'll be using the value aspect. Okay, so let's do this. Now we'll be converting to RGB to HSV, and then we'll again look at each aspect of what HSV, hue, saturation, and value. Okay, so we can see like how the saturation looks like for this particular image. Hue represents what actually? It represents the color aspect. Saturation represents the purity of the color. Okay, and value represents the brightness of the color. Okay, these are the some different aspects with respect to that image. Now what we'll do is, we'll have to create a mask to separate out our red balls from other balls. Okay, so here we have this range for the red color. Okay, and we'll be applying this as this mask to extract our red color balls from the image. Okay, let's get started. We are creating a copy of the image here again using NumPy, and then we are again applying this thresholding value and creating a masked image, and then again we are extracting that particular red balls mask, right? We are extracting that part alone. Okay, so if you see here, we have this red balls alone which is highlighted. So we can improve and improve this aspect, right? Like these balls are hidden here. Okay, so for that, if you want to see those values, we can change this value here and see. Okay, you can see now all the green and yellow, everything is appearing. Now if I reduce this to 100, again it will start disappearing. Okay, slowly it started disappearing. We'll see only red now. If I go and reduce it to what, 30, and this also to 30, so almost all the other colors are what, diminished now. We are not able to see anything. We are only able to see only the red objects. Okay, so we are able to detect the red color from here. So this is what happens, right, when you try to detect an object. Okay, it has to separate from the other objects, because there is, for doing that, we have what, something during that edge aspect, right? There will be an edge aspect, okay, where there is a contrast will happen. This red ball and this whatever the other color was present here, there is a huge difference between them. That's why we are able to extract our color from here. Okay, now what we'll do is we'll see something like this. Okay, this is in HSV format. Okay, how it will look in HSV format. So this will looks the brightness aspect, right? You can see how it looks like in HSV. So now we'll see the red color here. Once we do it in HSV, then again we are converting that into what, this one in red, what, RGB format. Okay, let's go back here, image. See, if you see here, right, we are converting that range. So here this is, we are using the HSV format of that image, and then extracting that particular color, okay, red color, and then we are using that masked image here to again back to what, RGB format. Okay, and then we are extracting the color. So let's see how different it is actually. So if you see here, there is this, if you see here, right, which is directly what applied on RGB. This is directly applied on RGB. This is applied from what, HSV we are applying. After applying HSV, we are turning it into RGB. So we can see the effective segmentation of color here. Okay, so we have covered a lot of things actually in this video. So we have understood, we have extracted the content from an image and tried to impose it on another image. Okay, and then we have did something color detection aspect. Okay, how it is done, and some of the features from OpenCV we have learned those things. Okay, so I guess we are almost done with this video. And another task what I can give you is, you can try to count these red balls, okay, based on this image. So that can be one of the tasks you can try from your end. Yeah, and if you did like this video, right, please do subscribe. And I'll be sharing this is basic part 1. I'll be sharing part 2, part 3 and part 4 in the upcoming videos. Thank you.